Question 7, acids and base. Acids and base, let's look at them. Okay, so 7.1, the pH of a solution X is measured before and after adding 10 drops of concentrated sodium hydroxide to it. 10 drops, 10 drops, 10 drops. Initial pH it is 7, it was neutral, and then the final pH it is now 12. So we now are sure that it is solution, it is now basic. What is meant by concentrated sodium hydroxide solution? It's just the definition of sodium base, but now instead of sodium base, you're gonna say concentrated base. You're gonna say a concentrated sodium hydroxide contains a large amount of base particles as compared to the water particles. So when something is concentrated, it contains more amount of contains large amount of base particles per unit volume. Okay, you can say per unit volume. Okay, instead of as compared to water, you can say per unit what? Per unit volume. Okay, concentrated, more number of particles per unit volume. This is fairly beautiful. Then let's continue. Then they say, what happens to the concentration of the hydronium ions? Remember the hydronium ions. What are hydronium ions? Concentration of hydronium ions in solution X. Write increase, decrease, or remain the same. Now, they say explain the answer in terms of ionization constant Kw. Now, initially our pH was 7, okay? So now they want you to use this formula. Concentration of H3O plus. Now remember Kw it is constant, it is 1 times 10. Actually, they want you to use this one to explain what's going to happen to the concentration of H3O plus. Remember this one it is constant. Okay, this one it is constant. So what happens as they add the concentrated sodium hydroxide? Remember sodium hydroxide has what? Has OH minus. So it means we are adding more OH minus. So we are adding more what? We are adding more OH minus. Then for this one to be constant, then it means this one needs to decrease. So it means for us to remain at constant, when concentration of OH minus increase, then those of H3O plus need to do what? Need to decrease. Okay, then how do we reason? When we reason, we're gonna say, since now a let me say hydroxide ions increase, the what? The hydroxide ions decrease. So hydronium ions decreases. Again, because why? Because Kw is constant, guys. Unless they change the temperature of water. Okay. So what's important is that since the hydroxide ion increases, then the hydronium ions will decrease. We have already answered that here. Okay, so this will be just another mark. But now, because why? Kw is constant, you need to indicate that Kw is what? Constant. We move on. Calculate the concentration of OH minus in the final solution. Concentration of OH minus. So we have So we will use the final pH, okay? The final pH. Now, remember when I want to calculate the concentration of OH minus, I can't use pH, okay? But remember, I know that pH plus POH is equal to 14. So the pH of that uses hydronium ions plus the one that uses hydronium ions, okay, is equal to 14. So hydronium ions and hydroxide ions. So I'm gonna say, okay, let me find my POH. Okay, let me find, since well I know that pH plus POH, it is equal to 14. I can say therefore POH, it is equal to 14 minus pH. Remember, we know the pH of the final solution, it is 12. Then pH, it is, sorry, POH, it is equal to 2. Then instead of using pH is equal to a negative log of hydronium ions, you're going to say POH, it is equal to negative log of hydronium ions, this case because we are using OH. Okay, guys, yes. And then it's just a matter of you being a mathematician, negative log, and then you are looking for the concentration of this one, which is OH minus. Guys, for you to do this, you're going to say OH minus is equal to 10 to the power of negative 2. You don't need to do anything fancy. Okay, 10 to the power of negative 2, guys. You don't need to do anything fancy. So when you say 10 to the power of negative 2 on your calculator, you'll get that this is the same as 1 times 10 to the power of negative 2 watt concentration mole per decimeter cubed. So yeah, I don't want to waste time on this one. What you can do, you can get pH. Okay, what you can, okay, I'll come back to this one if I have time and show you another step. Let's move on. 7.2. A learner titrates a sodium hydroxide solution with a standard solution with concentration of this one. So a standard solution with a concentration of this one. So basically this is the concentration of what? Of a standard solution had HCl. Okay, they say the learner uses a pipette to transfer 20 centimeter of sodium hydroxide solution into a conical flask and adds 2 drops of indicator. Okay, so we already have 20 centimeter cubed of what? Of sodium hydroxide into a what? Into a conical flask, and then an indicator is put there. The solution is then titrated with the hydrochloric acid. So they pour what? HCl here into our sodium hydroxide, and then until endpoint is reached. The titration is repeated 3 times. Okay, so the first one, the volume of HCl before titration was endpoint was reached, they added this one. Second one, they added this one, they added this one. So it means titration was reached, or rather endpoint was reached in different, by using different what, volumes. But I think if you were to measure the average, you'll get the exact volume. The average, I think it will be something like 20.10, but we'll see. Calculate the average volume. Okay, the average volume, it's just easy. Phi average is going to be 20.05 plus 20.15 plus 20.10 divided by 2, which is just 20.10 centimeter cubed. Okay, or you can divide that into decimeter cubed, is fine. Then they say prove with calculations that the initial concentration of the sodium hydroxide was this much. So we want to know the concentration of sodium hydroxide, the concentration, initial concentration. So we'll say, okay, the volume of HCl, the average volume, okay, remember we know the concentration of HCl to be 0.9, okay, 0.0958, and then we now know the average volume, okay, or rather the volume, let me say the volume, we're going to take the average volume because it is close to this one, okay, not necessarily all these trials but the average. And then we need the what? The concentration of the base. So I can use what? And I know the balanced equation, it is 1:1. I can use the titration equation that says, to me, concentration of acid multiplied by volume of acid divided by concentration of base multiplied by volume of base is equal to number of moles of A, where this is now, we take it from the balanced equation. Concentration of acid, remember we were told it is 0.0958 Can you see, guys? We were told here it is again. And then the volume, we're gonna use the average volume. Here you can use it in centimeter cubed, it's fine, as long as you can use the volume in centimeter cubed, as long as the bottom you're gonna use centimeter cubed also, which was how much? Remember, they just added 20, 20 centimeter cubed again, and then the ratio is 1:1. It is balanced. And then when you do your mathematics, you'll get that the concentration of the base, it is something like 0.0963 mole per decimeter cubed. Did we prove? Yes, it is the same indeed. The last question, the standard solution, okay, the standard solution, sodium hydroxide solution, is used to determine the percentage mass of this one in a commercial brand of blah blah blah. So remember now, we now know the standard sodium hydroxide again. It has the base, concentration of the base, we now know to be equal to how much? We now know the concentration of the base to be equal to 0.0963. It's now standard because we are using it and we know its concentration. Again, and the volume they will tell us. Okay, and then they say a 10-gram sample of rust remover is weighed off and transferred to the volumetric flask. Thereafter, the flask is filled with water up to 250 centimeter cubed. Then they tell you that 10 centimeter cubed of the diluted solution of the rust remover is titrated with this much of sodium hydroxide. So here we're going to use titration formula because it is titrated, okay? Just 10 centimeter cubed of the original 250, okay? And then the balanced chemical equation for this one follows here for the titration, okay? So they say calculate the percentage by mass of phosphoric acid in the original undiluted, undiluted thingy, okay? So undiluted, we want the mass of undiluted, okay? So this this is the, let me see, calculate the percentage by mass of phosphoric acid in the original undiluted rust remove. Oh, okay. So they want the what? The mass of phosphoric acid. So this one is just an impure. Okay. We can say yes, this one is the impure, basically. Impure. Okay. And then Rona, this one that we will use here, we will get the pure from this one. So basically, let's try to do what? Let's try to find the number of moles of these sodium hydroxide they use. Okay, then concentration, it is 0.0963 multiplied by the volume of, remember the volume, it is titrated on this volume again of sodium hydroxide, which is 0.0245 when I times 10 to the power of negative 3 or divide by 1000. So I get the concentration of sodium hydroxide used to be something like 2.34, 2.354 times 10 to the power of negative 3 what? Moles. And then let me use the mole ratio between NOH and this one. So remember this one, it is the one that has a volume of 10 centimeter cubed, guys. Remember this one because it is, can you see 10 centimeter cubed of the diluted? Can you see? Of the diluted guys solution is removed by this much, okay? So this one I'm gonna say, for me to find its number of moles, I'm gonna say number of moles between sodium hydroxide and and uh, H3PO4, it is 3:1, and then sodium hydroxide, it is 2.354 times 10 to the power of negative 3, and then this is x, and then I'm going to say x, which is number of moles of H3PO4 in 10 centimeter cubed. It is equal to how much? Okay, when I do my mathematics, I get something like okay, it's going to be something like 7.848 times 10 to the power of negative 4 moles. But this, it is the one found in 10 centimeter cubed. So how much is the one found in 250 centimeter cubed? Because we want to know from the original undiluted rust. So it's gonna be, if the original, so I'm gonna say I have 10, 10 over 250. Okay, the volume that I have, 10 centimeter cubed out of 250, I have it. Okay, I have it of the original. Okay, of the original H3PO4 in 250. Basically, what I'm saying here, it is 10 centimeter cubed of this original volume. Okay, 10 10 centimeter cubed out of the total 250 centimeter cubed, multiply by the initial concentration. I know it gave me how much? I know it gave me something like this one. Okay, it gave me something like, actually this is number of moles. I know that when I use 10 centimeter cubed, the number of moles of original, it gave me something like 7.848 times 10 to the power of negative 4. So if I get number of moles of H3PO4 in 250 centimeter cubed, it's going to be multiplied by 250 divided by 10, and then it gives me something like 0.01962 moles. Guys, this, it is in 250 centimeter. This one, then I want to know the original. The original, if 10%, if 10 centimeter cubed of the 250 centimeter cubed multiplied by the original gave me this, then for me to find the original, I need to multiply by the reciprocal, and then it gives me that, and then I can say, okay, number of moles is equal to mass divided by molar mass. I now know number of moles of the original again, and the mass is what I'm looking for, and then the molar mass of this H3PO4, it is 98, and then I get my mass to be something like 1,92276 grams. Am I done? No. What's the question requiring from us? Calculate the percentage by mass, okay, of the phosphoric acid of the origin. Basically trying to find what? A percentage purity. It's just you trying to find percentage purity. So this one, it is the pure one. Okay, so this one, it is the pure one. So percentage purity. Actually, this is the pure phosphoric acid found, because remember the process was what? Was uh, to determine the percentage mass of phosphoric acid in what? Rust remover. Okay, so the rust thereof contained of phosphoric acid and other impurities. So the percentage purity is going to be 1,92276 divided by 10 multiplied by 100. Where do I get the 10? The 10 from the impure. The 10 from the impure. Okay, the 10 from the impure. Then I get that percentage purity is 19.23%. This is what I get. This is what I get. Nah. And remember, I said on this one, I'll show you another alternative method. The other alternative method is to say, okay, let me find pH is equal to negative log of H3O plus, and then it's going to be 12 is equal to negative log of H3O plus, and then when you do your mathematics, H3O plus, it's going to give you something like 1 times 10 to the power of negative 12 mole per decimeter cubed. And then you still remember the formula Kw is equal to concentration of H3O plus multiplied by concentration of OH minus. Kw it is constant. Okay, H3O plus you know, OH minus you don't know. And then when you divide the off, you become a mathematician. Actually, when you substitute, you do this. And then OH minus, when you divide there, you'll see this is 12. You'll see that it will give you something like 1 to the power of negative 2. So the answer is the same. It's just a matter of you picking the sword that you think it's best for you to go to war. Again, guys, let's try to digest this one again. Let's try to digest this one again. So basically we have, okay, we have 10 grams of impure, okay, and they add what? They add 250 centimeter cubed of water, okay, to do what? To uh to is filled with distilled water of 250 centimeter cubed, okay. And then they tell us that 10 centimeter cubed of distilled solution of rust remover is titrated with that much. So they took what? 10 centimeter cubed of that thingy, okay, with whatever uh so now this one will contain H3PO4, that is pure basically. Remember, this one was impure, this one will be pure, and now it is titrated by what? By sodium hydroxide, and it is a standard solution of known concentration and known volume. Concentration and volume are known. Okay, you can apply titration thereof. Okay, when you apply titration thereof, you know that you'll get a titration. Actually, what you can also do, you can say, let me find the concentration of this one, because I already know its volume. I can say concentration of the acid multiplied by its volume, it is 10. Concentration of the base, it is 0.0963 multiplied by the volume, it is 0.2445 okay, it is equal to ratio of the acid. Acid it is 1, base it is 3, and then when you do your mathematics thereof, when you do your mathematics, it shouldn't give you a different answer. It shouldn't give you a different answer. Let me just quickly confirm. Uh, 0.0963 multiplied by 0.2445 divided by 30. So it gives me this answer, guys. 7.848 times 10 to the power of negative 4. What? Why am I getting concentration here? Let me see. Oh yeah, it's, let me see, 848, then I want to see something. 7 point concentration, and then the volume, and then the ratio is 1:2 thingy. Concentration of the acid here. Then let me see the number of moles. And use the number of moles. So if the concentration of the acid here, it is this much there, and then I can say what is the concentration of this one in a 10 That one, okay, this is in 10 centimeter cubed volume. So in 250 centimeter volume, it's gonna be 2 250 divided by 10 multiplied by 7.848 blah 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 blah. Then I think it's gonna give me this answer here, which is 0.01962. But this is concentration, mole per decimeter cubed. And then if I were to use C, it is equal to mv. Okay, let's see. Let's try to see that. Concentration, it is 0.01962. Mass, molar mass, it is 98. Volume, it is 250 originally. I don't know, but let me see. 98 times 250 times 0.1962. Well, I did not guess. I did not get the same mass I was expecting, basically. So no. So I'll just stick with the first method that we used there of this one. No, because here I don't know why this one is giving me concentration. This one give me number of moles, or maybe I don't need the concentration. Let me quickly confirm. 0.0963 times 0.0. Oh, okay. I think I see my mistake here. Here it is 0.2445. So this is negative 5, and then this is just going to be 0.0. This is m. This m here means molarity. It's the same as mole per decimeter cubed, but don't use it in an exam. And then let's see, 98 multiplied by volume of 0.25. Again, I'm gonna try that for the last time. I don't have time. 1962 times 98 times 0.25. Well, let me see if I use 0.1 instead. Well, if I use 0.1 here, 0.1, it gives me the same mass as 1 comma. Hey, bathong. Hey guys, I'm lying in shame. Yeah, if you can try to do it that way, it still works, guys. So I'll just end it there. Okay. So yeah, let's meet on question 8. Galvanic cell.